Welcome to the Explainer. Today, we're taking a seriously fascinating journey that starts deep inside the invisible, highly technical world of AI data centers and ends up right in your living room. We hear about artificial intelligence nonstop these days, but it's usually in these really abstract terms. Well, today, we're going to break down the actual physical reality of how AI is scaled and, most importantly, the tangible, everyday benefits this massive technology is bringing straight to you. Here's a quick look at our roadmap for today. We'll be hitting 1. The AI production gap. 2. Powering AI at scale. 3. Tuning AI for you. 4. Lower costs, better apps. And 5. Heating homes with AI. Yep, you heard that last one right. Let's jump in. All right, Section 1. The AI production gap. Before we get to the amazing real-world benefits, we really need to introduce the first major hurdle here. Why do so many brilliant AI ideas never actually make it to the public? Check out this staggering statistic from a recent Futurum Group report. Just 13% of enterprises have successfully moved beyond the experimentation phase to fully transformed production-level AI operations. That means 87% of companies are just stuck. They have an AI prototype, sure, but they can't actually deploy it at scale for everyday users to actually use. And when you break down the exact roadblocks causing that massive gap, you see issues popping up right from the proof of concept. Companies get locked into proprietary APIs, which basically traps their data. Then they hit major infrastructure bottlenecks, like they literally just can't get the GPUs they need to run their models. And finally, when they try to go into production, they struggle with massive performance drops and wildly unpredictable costs. Simply put, it's a logistical nightmare to scale AI properly. Moving on to Section 2, Powering AI at Scale. So to fix those bottlenecks and deploy AI properly, the industry needs massive, specialized, and above all, accessible infrastructure. This is exactly where solutions like the Nebius AI Cloud come into play to solve that deployment nightmare. To run complex AI, you need serious computing power without the massive headache of building it yourself, right? Nebius gives developers instant access to heavy-duty NVIDIA GPUs. But listen, it's not just about raw power, it's about orchestration. They use managed Kubernetes with GPU-aware scheduling. Now, I know that sounds highly technical, but it basically just means that the system automatically organizes and distributes the computing workload incredibly efficiently. Plus, they use dedicated GPU worker pools, so your intense AI workloads are completely isolated, meaning your app's performance won't suddenly tank just because someone else on the server decided to run a super heavy task. Because at the end of the day, the physical reality behind the cloud is just someone else's extremely powerful computer. We're talking massive racks of hardware in the data center, all connected by high-speed InfiniBand networking. That's what actually allows these huge models to train and generate responses without that noisy neighbor performance drop I was just talking about. But Nebius actually takes it a step further. They don't just go out and buy off-the-shelf parts. They are a vertically integrated cloud, which means they design their own custom motherboards and chassis, right from the hardware layer on up. And building this hardware from the ground up is absolutely crucial because it guarantees lower latency and predictable throughput. For sustained AI training, having that customized bare metal performance is the literal difference between an app that lags constantly on your phone and an app that responds instantly. Which brings us to Section 3, Tuning AI for you. Okay, shifting gears from raw compute power, let's talk about how these massive models are actually customized to be genuinely useful for specific tasks. Think of a general-purpose large language model as someone who speaks a language super fluently. They know a lot of broad information, sure, but their tone is totally generic and they definitely don't know your specific business. A fine-tuned LLM, on the other hand, is like a domain expert. It's the doctor who knows the exact medical jargon, or the lawyer who knows legal precedent, or the customer service rep who knows your company's exact return policy inside and out. Fine-tuning sharpens that model to deliver high accuracy for really niche workflows. And in reality, platforms like Nebius Token Factory make it incredibly simple to create these expert models. First off, a developer uploads a specialized dataset. Next, they fine-tune the model. Token Factory uses highly efficient methods like LoRa, meaning the developer doesn't even need to rent massive, expensive GPUs just for training. It's handled seamlessly right on the platform. And finally, with literally one click, they deploy it to a production endpoint. What used to take months of stressful infrastructure planning now happens in one unified workspace. All right, Section 4, Lower Costs, Better Apps. Now we get to the core of what this all means for you and me.
The crucial point here is captured perfectly by Prozis. They're the tech giant behind tons of the world's leading lifestyle and e-commerce brands, apps you probably use every single day. Their director of AI noted that Nebius allowed them to handle up to 200 billion tokens per day. Now, a token is basically a piece of a word. 200 billion of them a day is an unimaginably massive workload of data being processed just to give you better product recommendations, instant customer support, and lightning-fast search results.
And here is the absolute kicker. By using open-source models that are fine-tuned on efficient infrastructure like Token Factory, companies like Prozis are seeing up to a 26 times cost reduction compared to using closed, proprietary AI models. That is wild. And those massive business-to-business savings are a huge deal for all of us. Why? Because they don't just sit in a corporate bank account gathering dust. When a company's back-end AI costs plummet by 26 times, it allows their developers to integrate incredible, highly tuned AI features into the apps on your phone. We're talking better predictive text, instant smart customer service, highly personalized feeds, all without passing exorbitant software costs on you, the consumer. So this ultra-efficient AI infrastructure is quite literally funding the next generation of consumer tech that makes our everyday lives easier.
And finally, Section 5, Heating Homes with AI.
We're going to transition here to the final, and honestly, perhaps the most surprising real-world physical benefit of this whole technology. We usually think of data centers as massive energy hogs, right? But the physical reality is that all those server racks we talked about generate an enormous amount of heat. Because Nebius designs its own hardware and facilities from scratch, they achieve an incredibly efficient power usage effectiveness, or PUE, of 1.15. For context, the global average is around 1.54, and they pull this off largely by actually capturing the heat generated by the servers rather than just venting it away into the atmosphere like most places do.
Get this, between 2022 and 2024, the heat recovered from this massive AI computing captured over 50 gigawatt hours of energy. That heat was literally funneled straight into the local municipal heating network and warmed roughly 2,500 local households in Finland. Talk about the cloud having a direct, tangible impact on the physical world.
As the mayor of that Finnish town noted, the heat recovered from the servers warms homes and public buildings. This is the ultimate realization of what's in it for the common person. The invisible AI that's processing your e-commerce data and fine-tuning smart models is quite literally keeping local communities warm in the winter while strengthening the local energy system.
And that leaves us with a pretty fascinating paradigm shift. We have to challenge ourselves to view AI not just as some abstract software floating in the cloud, but as a physical engine with real-world potential. As this infrastructure inevitably continues to scale up, how can we ensure the physical footprint of our digital world continues to give back to our local communities? It's an incredible engineering challenge, for sure, but as we've seen today, the solutions are already out there, warming our homes and powering our daily lives. Thanks so much for joining me on this explainer. I'll see you next time.